All right, good morning, everyone. So I just played a video about um, a famous mathematician and probably one of the revolutionaries or one of the mathematicians who revolutionized the modern day mathematics. So it's Nicolas Bourbaki. And for those who missed it or missed part of it, you can search in YouTube "The Greatest Mathematician That Never Lived" by Pratik Aghor. So it's a TED video. Sort of telling us the story of Nicolas Bourbaki, who is basically a pseudonym for a group of mathematicians. Now, Nicolas Bourbaki, during his time or prior to his time, sabi nga dun sa video, napaka-pragmatized ng mathematics. Ibig sabihin, hati-hati yung mga concepts in mathematics, so much that a person working, say, in functional analysis cannot talk to somebody who is working on algebra because they employed different methodologies, different languages. But Nicolas Bourbaki is one of those proponents of unifying or at least putting a template or a common ground among all branches of mathematics. And true enough, what he did is to take advantage of the newly developed pero about 100 years old na set theory ni Zermelo Fraenkel. And they look at set theory as sort of a unifying groundwork for the entirety of mathematics. Kaya ngayon, sa modern times, makikita nyo, halos lahat ng mga theorems, mapa-algebra man yan, analysis, or geometry, all of these are predicated on some notion of sets. And that gave set theory a very big place in modern day mathematics kasi it transcends all other branches of mathematics. And that's why yung symbolic number na 101 na usually binibigay sa lahat ng foundational courses sa college, kasama niya yung set theory. Because you will need the concept of set theory in order to fully understand concepts in other math major subjects because they are always phrased in terms of sets. Okay? And we will now move forward into a more tangible and actually, paano ko ba sabihin, mechanical or sort of a technical discussion of set theory, beginning with the basic operations on sets. Kasi in the past few meetings, we just talked about the philosophical or the historical development of set theory as a field and as an axiomatic system. Last time, we finally resolved ano yung foundation ng modern set theory, and it's basically the 9 Zermelo-Fraenkel's column axioms, all right? And now, pupuntahan natin yung operations on sets. But a quick survey, have you guys encountered operation sets already? Like the union, intersection, set difference, cross product, ano pa ba? At least those guys. Naturo na ba siya sa AMAT 19 or Math 20? Oh, grade 7. Nice, Esther. That's very early. Pero sa Math 20 or AMAT 19, na-discuss na ba siya? Never pa ako nakapagturo ng AMAT 19 saka Math 20 in how many years of teaching na? About 12 years na pala ako nagtuturo pero never ko pa nakuha yung mga subject na yon. Okay, somewhat. So yeah, because I plan now to a little bit move the discussion pace a little faster para medyo makahabol tayo kasi ang coverage ng problem set natin, which by the way would be on November 29, would be operations on sets and the next chapter. May isa pang module supposedly na para sa na covered ng next problem set, but we still have a week to go. Pero yeah. And then that reminds me that please attend your lab sessions on Monday because I will ask your lab instructors to continue the discussions para lang medyo makahabol ako. So, with that said, kung medyo mabilis, papara kayo guys ha. So sabihin nyo kung masyadong mabilis. Okay? Now we start the discussion by talking about union, intersection, and the set difference. Okay? Now let's start with the union. And that's in definition 2.1.1. Or basically, I'll just call this definitions and this remarks by the last digit na lang. Alam nyo naman na 2.1 naman siya magsisimula. So in definition 1, we see what the union of sets is. And actually, we have already met the term union before when we look at the Zermelo-Fraenkel axiom of union. I think it's ZF5. Okay, so ZF5 nga ba? Yeah, I think so, ZF5. It says, definition 1 says that the union of two sets A and B, denoted by this guy, parang A, tapos mayroong matabang U, or pwedeng para siyang cup, right? Na naka usual position, okay? So A union B is the set uh, whose membership is determined by at least a membership in A or B. So ang mga members ng union ng mga sets ay mga members ni A or mga members ni B. So in symbols, we say that A union B is the set of all x's in the universal set such that x is in A or x is in B. So if you're a member of A, then you qualify to be a member of A union B. If you are a member of B, you qualify as a member of A union B. So in terms of Venn diagrams, so kung meron akong set A dito, tapos meron pa akong set B dito halimbawa, so ito si A, ito si B, ang union ni A at saka ni B, copyhin ko lang to guys, copy, alright? Ang union ni A at saka ni B ay yung lahat ng members ni A kasali, tapos lahat din ng members ni B kasali. Kasi ang connective dun sa definition ay OR. Ibig sabihin, kailangan ko lang maging member ng at least isa dun sa dalawang sets para maging member ng union. Okay? Kaya intuitively, madali rin siyang tandaan. Ang tawag sa kanya ay union, so sort of pinagsama lang natin yung mga members ni A at saka members ni B. Okay? Now, before going into an example, let's look at how the axioms guarantees the existence or the validity of the definition for the union. Okay? So kung babalikan natin yung mga ZF axioms, yung ZF4, which is I think the axiom of pairing, okay? So kapag ka meron tayong dalawang sets A and B, pwede ko siyang i-pair into the set containing A comma B. And now since there's a unique pairing of the set A and B by the axiom of pairing, okay? Kaya kong mag-define ng kahit na anong operation dito sa pair A and B. So basically, the axiom of pairing that we have seen last time guarantees the possibility of defining binary operations on any pair of sets. Kasi nga, unique yung pairing ng kahit anong dalawang set. Okay? So by the axiom of pairing, isang pair si A at saka si B, wala nang ibang posibleng pairing sa kanilang dalawa. Okay? And then the axiom of union, ZF5, guarantees na merong set na A union B. Because remember, it says that there is a unique set U, or actually hindi pala unique. Sinabi niya lang na there exists a set U such that the membership to U is determined by membership on A or membership on B. Okay? Now, some tangible examples. Let's consider the set A to be the set containing 2, 3, 5, and 7. Okay? And then the set B is the set containing 2, 4, 6, and 8. Now, to get the union of A and B, we'll simply collect the members of A and B and put them together inside a set. Okay? Dahil ang membership ay naka-OR, again, sufficient na maging member ng isa sa kanilang dalawa para maging member nung union. So yung mga members ni A, automatic members sila nung union. Okay? And then lahat ng members ni B ay members din ng union. So si 2, nasulat ko na siya before, so no need to rewrite it again because we said na not every distinct element of a set must be represented only once in the roster method. Okay? Isa lang lagi yung isinasama natin. Or isang beses lang natin siya isinusulat. 4 is a member of B, so it will qualify as a member of the union. 6 is a member of B, so it's a member of the union, as well as si 8. Okay? So yun yung konsepto ng pagiging union. And the more interesting sets to take the union of ay yung mga infinite sets. Pero kahit infinitely many yung laman nila, kaya pa rin nating i-qualify kung ano yung itsura ng union nila. Let's look at illustration number 4. If you consider the set of all integers Z, and the set of all rational numbers Q, okay? Pag kinuha natin yung union nila, ang makukuha ko ay si Q. Can anybody explain why? Bakit ang nakuha ko uli ay Q? Oh yes, Mitzi?
Sir, kasi lahat po ng integers ay rational numbers. So, parang yung integers po part na din po siya ng Q.
Okay, thank you, Mitzi. Yeah, that's right. Because if we draw the Venn diagram for Z and Q, so ito yung set ng lahat ng rational numbers, right? Yung mga integers kasi, pag meron kang integer P, pwede ko siyang isulat as P over 1. And that makes it a rational number. So inside Venn diagrams, pwede kong i-drawing si Z sa loob ni Q. Tama? Or in other words, in terms of subset relations, how can I express the relation between Z and Q? So nga, in terms of subsets. Who is a subset of which, or who is the superset of which? Yes, Mary Rose.
Hello po. Hindi po pala
Hi.
ako Sir,
Yeah.
is it Z is a subset of Q po?
Okay, thank you, Mary Rose. That's right. Si Z ay subset ni Q kasi lahat ng integers ay rational numbers din. Or equivalently, you can say that the set of all rational numbers is a superset of Z. Mas malaki kasi si Q kesa kay Z at lahat ng na kay Z ay na kay Q. So this gives us a way, okay, pag Venn diagram ko pala yan, pag sinabi kapag ka union, dapat i-shade ko lang yung dalawang sets together, all right? And what I get if I shade the corresponding diagrams for Z and Q, kinuha ko yung union, Q lang pa rin yung merong shade, all right? So we say that, okay, at least graphically, we say that the union is equal to Q. All right? And actually, it's a nice observation na kapag ka pala tinanggal ko yung label na Q at saka si Z, tapos tinawag ko lang to na set A at saka si set B, it seems that the observations still follow. Kahit rational sila or kahit hindi sila Q or hindi Z, palitan ko lang sila ng generic elements A and B or generic sets A and B. Pag si A ay subset ni B, mukhang ang union noong dalawang sets ay yung mas malaking set B. Because again, if I do the shading here, shade si A, i-shade si B, tapos ang membership ng union ay yung lahat ng may shade. So that means it seems that it is equal to B. All right? And I hope that's the next, hindi pa pala siya yung next theorem, but reserve that thought for, sige, siguro i-prove na rin natin na una na eh. Theorem 8. So that observation is encapsulated in Theorem 8. It says that if we have two sets A and B, where A is a subset of B, then it follows that the union of A and B is the set B. Okay? So if we will write the proof here, gusto kong mag-prove ng equality ng dalawang sets. So what I want to show here is that, okay, equality ng dalawang sets. So by ZF2 or the axiom of extensionality, gusto kong ipakita na X element of A union B if and only if X is an element of B. All right? But with the assumption that A is a subset of B. Okay? Tapos sa try natin gawin to via the definition lamang. All right? Now, let's try to write the proof here, though nandiyan na yung proof sa gilid, but let's recreate the proof, right? So again, our assumption here is that A is a subset of B. And we want to show the equality of two sets. But again, the axiom of extensionality gives us a nice way on how to prove equality of two sets, right? So first, I'll consider an arbitrary element of the first set, A union B, all right? By definition, it says that X is an element of A or X is an element of B, all right? But so far, this is an if and only if statement kasi definition yung ginamit ko, right? So kung ito-try natin tong i-prove posibleng tingnan natin kung kaya natin siyang gawing isang biconditional proof para hindi na natin hahatiin yung proof sa dalawang parte. Okay? So, try lang natin. Baka naman pwede na dire-diretsong if and only if yung makikita natin. So, if we'll be able to show that X element of A union B, if and only if X is an element of B, then that's fine. That's the end of the proof. But if in one of the steps here, we were forced to use a single implication, then ibig sabihin kailangan ko nang hatiin yung proof sa dalawa. Okay? But so far, we have an if and only if statement. Our goal is to reach X element of B. Kaya lang, ano yung alam natin? Well, we know that since A is a subset of B, okay, then X being an element of A implies X is an element of B. All right? Definition ng pagiging subset. Right? So the idea here is if you have an X element of A, then for sure it will imply that X is an element of B. So this part of the disjunction here can be replaced by X element of B by hypothetical syllogism. Or hindi pala hypothetical syllogism, by modus ponens, right? We know that here X is an element of A, but X element of A implies X element of B. So by modus ponens, or confirming or we have satisfied the antecedent, so therefore the consequent will follow. But that is a rule of inference. So that means, so we have X element of X element of B or X element of B. Mali pala. Hindi pala union yung gamit ko rito. Dapat or. Okay? Or siya dapat kasi tinranslate ko na siya into elements. Alright? So, and then, this is P or P. So, pwede natin siyang i-simplify into X element of B. Okay? So, nawala natin yung pagiging biconditional kasi gumamit ako ng modus ponens here. And remember, modus ponens is a rule of inference. So, one way lamang yung modus ponens. I cannot get from here pabalik dito kasi one way lang yung modus ponens. Alright? So, ibig sabihin, napakita ko pa lamang dito that if X is an element of the union, and with the assumption that A is a subset of B, then it will follow that X is an element of B. Or in other words, we can say that A union B is a subset of B. All right? So ito lang yung napakita natin. Wala pa yung equality, so I'll need to do the other half na nire-require ng axiom of extension. So here I will assume now we consider an X element of the set B. All right. If X is an element of the set B, then X is an element of A or X is an element of B by addition. Okay, remember, addition is a valid rule of inference. Pag meron ka ng statement o proposition na alam natin to be true, pwede ako magdagdag sa kanya ng isang disjunct. So pwede ako magdagdag sa kanya ng kahit na ano with a connective or, because basically that's the rule of addition. Okay? But the rule of addition is a rule of inference. So ibig sabihin, one way lang din ito. Mula dito, i-imply niya ito. But from here, we cannot jump papunta kay X element of B without any other condition. Okay? Kaya nakita nyo dito, kinailangan ko talagang hatian yung proof sa dalawang parte. Okay? So, but essentially here, this guy that we have so far is the very definition of being in the union of two sets. X element of A or X element of B. So that means X is an element of A union B. Okay? So therefore, we have shown here that X element of B, implies X element of A union B. So that's the very definition of being a subset. Okay? So B ay subset ng A union B, but we have proven earlier, or we have shown earlier, that A union B is a subset of B. So by the anti-symmetry property of subsets, we can say that A union B is equal to B, provided that A is a subset of B. Okay? Okay, is the proof clear, guys? Okay, thank you. I hope hindi siya masyadong mabilis. Oh yes, Gad, you have a question?
Sir, pwede ko screenshot, sir.
Oh, sure. Yeah. Yan, hopefully cash na siya.
Okay na po. Thank you, sir.
All right. Yeah, although the proof is also written in the actual work text, gusto ko lang siyang i-rework para para kasabay ko kayo sa thought process, okay? And I hope that's fine. And usually this is how I read books. I find it really helpful. Kahit sa mga books, meron na siyang mga proof sa gilid. Meron na siyang proof sa actual discussion niya. Pero I always find it helpful if I can write the proof on my own on the margins. So, parang training na rin ito sa inyo, paano magbasa ng isang libro. Kasi nakita ko ngayong problem, lalo na sa mga, ano ba kayo, millennials or Gen Z na parang nasanay na kayo sa bullet form. And probably most of the modules that you were given probably were also bulleted in form. Kaya medyo sanay tayo makabasa ng memes or tweets lang ng 140 characters, pero nawala yung konsepto ng pagbabasa ng books. So merong mga skills na nawawala. So that's why I decided na dito sa Math 101, ipapakita ko sa inyo yung work text. Hopefully babasahin natin sila kahit hindi line by line, pero at least diagonally. So you will be refreshed and reminded on how to read a book. Okay? So ganun yung idea dito. Kaya minsan kahit nandito na yung theorem or yung proof ng theorem, I want to write it or I want to rewrite it again with you guys, okay? Now, before we proceed to the next operation, there's another important property here. If you take the union of any set with the empty set, the answer is the set itself back, okay? Which kind of makes sense kasi ang idea rito ay, okay, A union the empty set. So ibig sabihin, kokolektahin ko lang lahat ng members ni A at saka lahat ng members ng empty set. Kolektahin ko siya into another set, I'll get the union. Okay? Pero pag pinagsama-sama ko yung elements ni set A at saka nung set na walang laman, ang makukuha ko lang pabalik ay yung set A again. Kasi walang contribution yung empty set kasi wala siyang kayang i-contribute. Okay? So if we'll write the proof for that, okay. So again, here we want to show that A union the empty set is equal to A. Okay. So, yun uli, axiom of extensionality. Gusto nating ipakita na ang isang element nung nasa kaliwa ay element din nung nasa kanan and vice versa. And we'll be lucky if we'll be able to use biconditionals para isang pasada lang yung proof. And let's see if that will work. Okay. So I will let X be an arbitrary element of A union the empty set. And by definition, this means that X is in A or X is in the empty set. Okay? So we have a disjunction here. However, we know the second statement is false kasi X cannot be an element of the empty set because the empty set contains nothing. All right? So we know this guy is already false. So ano yung pwede kong conclusion? At saka ano yung rule of inference na gagamitin ko? Anyone? Nakataas pa yung kamay ni Gad. Gad, may idea ka ba? I think nakalimutan mo ibaba pero dahil naka-raise ka pa rin. Do you want to try? Sige, kung ayaw ni Gad, yes, Daniel?
Disjunctive syllogism po. You'll get X is an element of A.
Okay, thank you, Daniel. Yeah, that's right. By disjunctive syllogism, we know that the second disjunct is false. Para maging true yung disjunction, dapat totoo yung una kasi false na yung pangalawa. So, but again, this is a rule of inference. So one way lamang yung conclusion ng disjunctive syllogism. So, hindi na natin kayang isang pasada lang yung proof. Kailangan ko na siya talagang hatian sa dalawa. But essentially, what we get here is that A union the empty set is a subset of the set A. So we want to show sort of the converse, yung kabaligtaran naman niya. So now, we will take an element X of the second set. Okay? Tapos gusto kong mapakita na tong X na to ay element ng A union the empty set. But that is easily, or that can easily be done by using addition. So this is by addition, which is another rule of inference, kaya one way lamang yung arrow. Okay? Rule of inference lang siya. Kapag meron kang true statement, kaya natin yan dagdagan via an or ng kahit anong statement, be it true or be it false. All right? But I specifically chose to add x element of x element of the null set as my second disjunct because that is what is required to be in the union of A and the empty set. Okay? So therefore, we have shown here that x element of A implies x is an element of A union the empty set. Okay? So, ito yung na-conclude natin, yung subset relation. And again, by the anti-symmetry of the subset relation, yung kaliwang set ay subset nung kanan, yung kanan subset nung kaliwa. So therefore, equal silang dalawa. A union the empty set is equal to A. Or you can also say it's the axiom of extensionality. So if X is an element of A union the empty set, then X is an element of A. And vice versa. If X is an element of A, then X is an element of A union the empty set. So napakita natin na X is an element of A if and only if X is an element of A union the null set. So by the axiom of extensionality, A union the empty set is equal to A. Okay? Is that clear, guys? Okay. All right, so let's move on. May tanong ba sa union? Iiwanan ko na yung union. Ang focus natin ngayon ay hindi lamang pagkuha ng mga union ng mga specific sets, pero yung pagpo-prove ng mga properties ng union. So at least here we have seen sort of the basic properties of the union, and probably later we can combine it with other set operations, okay? Now let's move on with the second operation, which is the intersection of two sets, and that's in definition 9. So the intersection of two sets A and B, denoted by this guy. If you're writing things in LaTeX, ito yung tinatawag na cap notation. So parang baligtad na union. Sa LaTeX, ang tawag sa kanya ay cap kasi para siyang sa club daw. Pero parang Lincoln hat siya or topside hat. So A intersection B is the set of all x's that belong to both A and B. So kung kanina sa union, ang connective ay or, sa intersection, ang connective ay and. So ibig sabihin, para maging miyembro ng intersection, dapat element ka ni A at element ka dapat ni B. So if we'll draw a Venn diagram for this set, okay? Ito uli yung set A, ito yung set B. So dapat member ka ni, oops, sorry, what happened? There we go. Okay, so ito yung elements ni A. Tapos ito yung elements ni B. Okay. Para maging element ng intersection, dapat na shade ka ng kulay yellow at na shade ka rin ng kulay blue. Kasi ang usapan, dapat member ka ni A at member ka ni B. So ibig sabihin yung intersection, ito lamang. The common elements between A and B. Okay? Dapat na shade ka twice. So si A, itong element na to, tawagin nating X, wala siya sa intersection kasi na kay A nga siya, pero wala naman siya kay B. Remember that the connective and requires the both propositions to be true. Okay? So element nga siya ni A, pero hindi naman siya element ni B, so wala siya dapat sa union. Okay? And again, the existence of the intersection of two sets is guaranteed by the axiom of pairing and the axiom scheme of subsets. Okay? Axiom of pairing, pwede mong ipag-pair si A at saka si B, defining a unique binary operation on them. And then by the third Zermelo-Frankel axiom, yung axiom of scheme of subsets, ang membership kay intersection dapat member ka muna ni A. Pwede mo tong tingnan as the underlying universal set or yung pool of candidates para maging element ng intersection. Tapos pipiliin mo pa further sino sa mga elements ni A yung magbe-belong sa intersection. Yung property P na gagamitin natin para ma-determine sino dun sa mga members ni A ang members ng intersection, okay? Ay isi-set natin yung property P na yon to be X belonging to B. Okay? So kaya guaranteed na nag-exist yung intersection. Okay? And then to see this in action, let's consider example 11. So we have here the letters of the word love in set A. Okay. And then in set B, these are the letters in the word hope. And then if we get the intersection, okay, pwede yung unahing candidate yung mga elements ni A. Sila yung mga candidates dun sa intersection. Pero ang property na mag-verify o magsasabi sa atin kung talagang member siya ng intersection ay yung pagiging member ni B. Si H ay wala sa pool of candidates kasi ang pool of candidates natin ay si A lamang. So ibig sabihin hindi na siya kasali kasi wala siya sa possible members ng intersection. Okay? Si O ay na kay B and si O is among the choices to be in the intersection. So O will indeed belong to the intersection. B is not a candidate in the intersection or to be in the intersection because it doesn't belong to the set A. So wala siya talaga, but the set E, or sorry, the element E is in B, and it is also in E, it's also in A, so it is a candidate. So ibig sabihin si E nandun din sa intersection. So we say that the intersection of A and B is the set containing O and E. Okay. Now another illustration in terms of infinite sets, let P be the set of all prime numbers and E plus be the set of all positive even integers. Then I hope you will find it obvious na yung intersection ni P at saka ni E plus ay yung set containing 2. Alright? Kasi dapat yung mga elements ng intersection, mga prime numbers, and at the same time, dapat even positive integer. Okay? And there's only one such element, si 2 lamang. Okay? Kasi any even integer greater than 2 will become a composite number. Hindi na siya pwedeng maging odd. Okay? So let's see. Can anybody help me with exercise 13? So ano daw yung intersection or wala pa pala yung tanong? Ano yung intersection ni R at saka ni Q? Yes, God.
No, sir.
Yes.
Q po, sir. Q.
Sorry, what's that? Okay,
Q.
That's right. Thank you. So, lahat kasi ng mga rationals ay real number din. Pero hindi lahat ng real ay rational. Rational yung intersection. Yeah, that's correct. How about letter B? Q intersection Z. Yes, Zaira?
Sir Z po.
Okay, thank you. Yung sila yung intersection. That's right. Next, about Z intersection R. Yes, Imison?
It's Z po.
All right, thank you. That's right. And then last, Z intersection the empty set. Yes, Mary Rose. Nakasagot ka na ba, Mary Rose?
Yes po, sir.
Okay, sige. Tawagin ko muna si John Flor. Hi, John Flor. Parang ngayon ko lang siya na... Hi. How about Z intersection the empty set?
Yung null set po.
Okay, thank you. That's correct. All right. So yun yung pagkuha ng intersection. And then let's move on quickly to proving some important properties of intersection. Pero balikan ko lang sa union pala. Hindi ko na prove na ang union ay commutative. I don't know kung na-mention siya dito sa mga theorems. Pero dagdag natin kung hindi siya nasabi. A union B is the same as B union A. And the proof is quite easy. Gagamitin ko lang yung pagiging commutative ng OR. So if X is an element of A union B, that happens if and only if X element of A or X element of B. Yan yung definition. Pero commutative ang OR. So, and that's a biconditional statement then. So it means X is an element of B or X is an element of A. But this guy is the precise definition of B union A. So we can say here that X is an element of B union A. So by the axiom of extensionality, we can say that A union B is equal to B union A. In other words, the ordering of the sets in the statement of the union doesn't matter. Kasi pwede natin siyang baligtarin, and the basic idea is that it is hinged upon the commutativity of the connective OR. Okay? Nabasa niyo ba siya dun sa vortex? Hindi ko alam kung nabanggit siya or hindi, pero this is a nice property of the union. Another nice property, sige, I think yun na yun sa union. Sa intersection, meron din tayong similar property of commutativity. Ang intersection ay commutative din. So I can just replace the statement in this theorem by caps here. Okay. Ang A intersection B ay equals to B intersection A. And I hope you can guess by now, similar yung proof na gagamitin ko. Lahat lang ng union, papalitan ko lang ng intersection. Okay? And dun sa definition kasi niya, instead ng OR, and yung ginagamit natin. But that is not a big deal because and is also commutative. Commutative yung connective na and. So yung X element of A and X element of B ay kaparehas lamang or is equivalent to saying that X is an element of B and X is an element of A. So kung yung proof ng commutativity ng union ay nakaangkla dun sa commutativity ng OR, yung commutativity ng intersection ay nakaangkla naman sa commutativity ng connective na N. Okay? So I hope that's an obvious result here. Okay? And then, babalikan ko yung previous example dito. Nakita natin dito na Z intersection the empty set is the empty set. And this is not hard to see. All right? Kasi walang members si empty set. So ibig sabihin wala tayong candidate para maging element ng intersection. Kasi nga para maging element ng intersection, dapat element siya ng parehas na sets. Pero yung pangalawang set natin ay empty set, wala siyang laman. So imposible na merong element na makasatisfy ng X element of the null set. So therefore, walang laman yung intersection nila. And basically, that is what is proven in Theorem 14. Sabi niya sa kahit na anong set, ang intersection ng set na yon at saka ng empty set ay empty. All right? And usually, to prove something is an empty set or is equal to the empty set, proof by contradiction yung ginagamit natin. So let's try to do that here. Okay. So here, we want to show that A intersection the empty set is the empty set. And we're going to do the proof by contradiction. Okay. So we suppose for the sake of contradiction that A intersection the empty set is not empty. All right. So kunwari, mali yung theorem. Ano yung magiging contradiction? Hahanap tayo. Okay? So then, if this is non-empty, then there exists an X such that X is an element of A intersection the empty set. Okay? So, yun yung sinasabi niya. Kung meron siyang laman, di tawagin ko yung laman niya ay X. By definition of the intersection, I can say that X is an element of A and X is an element of the null set. Oh guys, be careful when writing things like this. Sana makita niyo yung shift kung kailan ginagamit yung intersection at saka yung and. Okay? Yung intersection, ginagamit lang natin siya sa pagitan ng dalawang sets. Okay? Dapat set yung nasa kaliwa niya, set yung nasa kanan niya. Yung and, ginagamit natin siya kapag proposition, yung nasa kaliwa niya, at proposition din, yung nasa kanan niya. So pag ginawa niyo itong intersection, it doesn't make any sense because the intersection requires two sets to be involved. Pero propositions yung meron tayo. So pag ganito yung ginawa niyo sa proof, medyo ma-minusan ko kayo ng konti. So be careful with the use of the symbols, okay? All right, so we have X element of A and X is an element of the empty set. But by simplification, I can take X element of the empty set, okay? So again, this is by simplification or SP, all right, from our rules of inference. Pag meron kang and, pwede mong kunin kahit alin sa dalawang conjuncts kasi true naman sila parehas. But this guy is a contradiction over here. Bakit siya contradiction? Kasi X element of the empty set. Wala namang laman si empty set. So there is a big contradiction here. So therefore, we must accept that our supposition here is wrong. So that means A intersection the empty set is necessarily empty. Okay? So, and then this is a usual proof on how to show that something is empty. Assume that it is not empty, then find a contradiction. Okay? Now, some other properties of the intersection of two sets. I think we have proven exercise 16, yung commutativity ng intersection. Okay? And then theorem 17 is a nice statement. Kapag raw meron kang A na subset ni B, then yung A intersection B ay equal daw kay A. So kabaligtaran naman siya nung, or actually parang kamukha siya nung nasa union, pero yung mas maliit na set yung sagot. Kanina, kapag ang A ay subset ni B, yung union niya ay yung mas malaking set. Pero ngayon, ang intersection ay yung superset. Ang intersection ay yung subset. Okay? And we can draw, we can take, or we can get an intuition about this by drawing a Venn diagram. Si A daw ay subset ni B. So, ibig sabihin si A, naninirahan siya sa loob ni B. Okay? Tapos, para maging element ng intersection, dapat pag kinulayan ko si A ng yellow, tapos kinulayan ko si B ng red, ang elements ng intersection ay nakulayan ko ng parehas na kulay. So that means the intersection will simply be this guy, which is exactly A. All right? So yun yung intuition behind Theorem 17. And of course, we are doing formal mathematics here. We will not just be content with an intuitive proof or a pictorial proof. So gawin natin yung formal proof dito. Okay? So we are assuming that A is a subset of B, and we'll want to look at A intersection B. Okay? So perhaps let's start with taking an arbitrary element of the intersection. Okay. So this means X is an element of A and X is an element of B by definition. Okay. But X element of A implies X element of B. So I can use the modus ponens again. But okay, I guess Gad has a question. Yes, Gad. Or napindot lang yata ni Gad? Okay. So
Sir,
I hope
sorry,
every...
napindot lang.
Oh, no problems. Okay, so I hope it's clear kung paano ko to nagawa, right? So again, modus ponens ulit. Pag si X element daw ni A, imply niya na si X element of B. Pero meron tayo ditong X element of A. So by modus ponens, which is a rule of inference, so one-headed lang, single-headed lang yung arrow. So that means X element of B and X element of B. All right? So yung X element A dito napalitan ng X element of B. And by idempotency, X element of B and X element of B, that implies X element of B. All right? So what we have shown here, if we have an X element of the intersection, it follows that X must be an element of B. So in other words, we have shown that the intersection is a subset of B. All right. Now we will do the other way. So now we will assume X is in B. All right. So kung si X ay na kay B, paano ko mapapalabas na element siya ng intersection? Or actually, hindi pala. Sorry. Hindi, tama. Equality yung gusto nating ipakita, no? Okay. All right. So now, how can we show that B is a subset of A intersection B? Yes, Mitzi?
Sir, since 2 po yung X is an element of B, we can add X element of A po by addition po.
Oh, but remember, Mitzi, ang addition ay OR, yung nadadagdag.
Oh, okay po.
Hindi pa ako sure na si X ay element ni A, right? So, or actually, sorry, mali pala yung pinuprove ko. Kaya hindi ko alam yung susunod na gagawin. Ang assumption nga pala natin ay si A ay subset ni B. So dapat ang mapakita ko ay, sorry, mali yung proof ko, ay si intersection ay equal kay A at hindi kay B, alright? So, erase that. Kunwari, wala pa akong ginagawa, alright? So, ibig sabihin nito ay, tama pala, X element of A and X element of B. Gusto ko nga pala ipakita yung intersection ay equal kay A. Alright? So, dito pala, sa unang side, gagamitin ko lang ay simplification. Alright? So, I can simplify it to X element of A. Alright? And that means that A intersection B is a subset of A. Tapos, ang gusto kong ipakita ay yung A ay subset ni A intersection B. Okay. Mali pala yung pinuprove ko kanina. Sorry, guys. Masyado pa kasing maaga eh. So, yan. Yun yung kalahati. Yung second half is I will consider an element of A. Hindi element ni B. Kasi yung intersection ay equal kay A. Hindi equal kay B. So, ngayon, kukuha ko ng element ni A. But if X is an element of A, then X is also an element of B since A is a subset of B. All right? So alam ko na ngayon, by assumption, si X ay element of A. By modus ponens, si X ay element din ni B. So therefore, X is an element of A and X is an element of B, which is the very definition of being in the intersection. Okay? So we have shown that A is a subset of A intersection B. And by the anti-symmetry of the subset relation, we can say that A intersection B is equal to A, provided that A is a subset of B. All right. Baliktad pala yung pinuprove ko kanina. Kaya hindi ko alam yung gagawin dun sa second half. Ibig sabihin kulang pa sa kape, ano? So, yun. Okay. I hope that's clear again. Sorry for the boo-boo there. Okay lang ba, class, if I, again, borrow 5 or 7 more minutes? Tuloy ko lang. If you have to go, you can. Balikan nyo na lang yung recording. Gusto ko lang matapos yung set difference. Okay. Now, let's see. Okay, conclusion na pala to ng section 2.1. Definition 18, pangatlong set operation natin ay yung set difference. Okay? The set difference of A and B denoted by A minus B. So dito sa Vortex, ang ginamit niya ay yung usual minus. Pero usually, ang notation ko sa A minus B ay A backslash B. Okay? So kaya minsan pagka handwritten ko yung solution, makikita nyo ay yung backslash instead na minus. Okay? A minus B is the set of all x's in A but not in B. Okay? Dapat na kay A siya muna. Tapos yung property P niya, si X dapat ay wala kay B. So ang candidates para malagay sa A minus B ay lahat ng elements ni A. Kaya lang, unti-unti nating babawasan yung mga candidates na yon by crossing out lahat na nagbe-belong kay B. Okay? So in Venn diagrams, okay. So ito yung mga elements ni A. Tatanggalin ko sa kanya yung mga elements ni B, yung mga makikita ko rin kay B. So ibig sabihin matatanggal ito. Ano kayang kulay yung gagamitin ko? So gamitin ko na lang ay black. Matatanggal itong mga na kay B. So the pool of candidates to belong to the set difference would be the members of the first set. Kaya lang mula dun sa mga members ng unang set, tatanggalin natin yung mga nakikita natin dun sa second set. Okay? So what we have here is this guy. This is A minus B. All right? So perhaps a more tangible example, let's consider example 20. In example 20, we have the set A is the first 4 prime numbers, okay? And then the set B is the first 4 positive integers or positive even integers. Then kunin natin yung A minus B. Again, sa A minus B, ang candidates ay yung elements ni A. Okay? Tapos tatanggalin ko lang lahat ng elements ni B. So si 2, na kay set B siya. So tanggal na siya. Si 3, wala siya sa set B. So retain siya sa set difference. Si 5, wala kay B. So retain din siya. Si 7, wala kay B. So retain din siya. So A minus B then is the set containing 3, 5, and 7. On the other hand, if we take B minus A, all right, sa B minus A naman, ang candidates natin ay mga elements ni B. Tatanggalin natin mula sa kanya lahat ng makikita natin kay A. Si 2 ay na kay A, so tanggal siya. Si 4 ay wala kay A, si 6 wala kay A, si 8 wala kay A. Kaya yung B minus A is the set 4, 6, and 8. Okay? So in this example, we already learned that the set difference is not commutative. Nagmamatter yung ordering sa set difference. Kasi pag pinagbaligtad mo yung order, posibleng iba na yung set na makuha mo. Okay? So kindly play with exercise 21. Probably I can give you the answers here. Mabilisan. A minus B would be 1 and 1 and 2. Tama ba? Kasi si 3 at saka si 4 ay nasa kabilang set. Ang B minus A naman ay 5, 6, 7. So this is another illustration that set difference is not commutative. Right? And then, okay, and then probably, let's see. Sige. Ano yung set If A is any set, what is A minus the empty set? Can you guys tell me what is A minus the empty set? Okay, John Rensis?
Set A po.
Set A? Good. Bakit set A?
Since wala naman po silang intersection. So lahat po ng elements na kay A is yun din po yung kasi pag A minus na set po, ang matitira lang rin po is yung set A.
Okay, thank you, John Rensis. That's right. Kaya sabi nga natin, ang candidates natin ay si set A. Tapos tatanggalin ko lang lahat nung nandun sa second set. Pero yung second set, wala naman siyang laman, so wala akong tatanggalin mula kay set A. Alright, so that's good. How about if I reverse the order? What is the null set minus the set containing A? LG?
It will still remain as the null set.
Okay, great. It would be the null set. Okay. Dahil, ano yung mangyayari? Ang
Since-
candidate... Okay,
Ay.
sige. Elgin, go.
Sorry. Since wala naman pong, yung candidate po ay null set, wala pong matatanggal sa kanya since in the first place, wala naman po siyang laman.
Okay, good. So, dahil tama yon, ang candidate, wala kang candidates. So, kahit wala kang tanggalin o magtanggal ka ng napakarami, wala pa ring matitira. Alright? Kasi to begin with, wala naman talaga. Alright? So, that's the empty set. So, parang, dito pala walang negative kasi minsan nakala ng mga estudyante yung empty set minus set A cannot be. Hindi siya cannot be kasi ang sagot sa kanya ay empty set. Meron pa rin sagot, pero wala nga lang laman yung sagot. Okay? And then, how about this? Ano yung subset relation nito? Actually, medyo obvious pala yung pagkaka-phrase ko ng example. But it can be proven that what? Okay, tama pala. Sino yung subset nino? Si A at saka si A minus B. May subset relation ba sila? Yes, Daniel, kahit alam ko nakasagot ka na. Sige, si Victor muna. Sorry, Daniel. Go
Sige.
ahead, Victor. Yeah, sorry, Daniel, nakasagot ka na nga pala. Sige, Victor Luis, may subset relation ba dito sa dalawang sets na to?
Hello, sir. Marinig ako, sir.
Yep. Hi.
Hello, sir. Most likely, ang subset dito would be A minus B. Kasi they're from both set A. You already took away some elements which are part of the set B. So in comparing the two, there would be most likely less elements left in set A.
Okay,
in the
great.
second part.
Yeah, great. That's correct, Victor. Kasi nga, ang candidates natin ay mga nanggagaling kay set A. So at best, walang matatanggal. So A equals A. Pero pag merong natanggal, alright, so ibig sabihin yung A minus B ay mga elements pa rin ni A, pero hindi lahat ng elements ni A. So yung set difference should live inside the set A pa rin. Kasi nga, dito nanggagaling yung candidates. Walang lumalabas kay set A. So that's correct. Ayan yung subset relation. Kailan nangyayari ito? When does this happen? That A is a subset of A minus B. Sige, Daniel Noel. Kailan kaya ito pwede mangyari? Or pwede ba yung mangyari at all?
Yes po. If B is the null set.
Okay, if B is the null set, that's correct. Kasi magiging A minus B equals A lamang. Alright? Kasi ang A minus the empty set ay A lang naman lagi yung laman. Okay, great. Yun lang ba yung case na pwede itong mangyari? Yes, Imisan, can you think of another way kung kailan mangyayari itong subset relation na to?
Ano po, sir? Pag wala pong element ni A na nag-exist kay B.
Okay, great. That's another possibility. So A will become a subset of A minus B if, okay, CA ay disjoint from B. Ayun pala, hindi rin na-define no, or nakalimutan ko lang basahin. We say that A is disjoint from B if and only if their intersection is empty. Or we can also say that A and B are disjoint if and only if wala silang common elements. Okay? And this subset relation will be true if A is disjoint from B. Pag walang common elements mula kay A at saka kay B. Kasi may imagine nyo na kapag wala namang common elements saka si A at saka si B, yung A minus B ay magiging equal pa rin kay set A. Probably that would be a good exercise to prove. Malay nyo makasama siya sa problem set. Okay? But I guess I consumed all of our time for today. Thank you guys for sticking around. So just a final reminder, please do attend your lab class on Monday. So kasi ipapadiscuss ko sa kanila yung, or sa lab instructors nyo, yung complement of a set together with the rest of this study guide. Para tapos na tayo ng study guide 10, pwede na ako mag-study guide 11 next week. All right? Any parting words or any final questions? Sorry, medyo minadali ko yung discussion today, but I hope you still got the gist of the topic. So if you have some questions, feel free to reach out to me. You can reread the work text, it's already there. So if you have questions, just let me know, okay? If there are no other questions, then... Oh, worksheet number 8. Good question, Esther. Perhaps let's move worksheet number 8 on Friday next week. Will that be fine? Friday na lang yung deadline ng worksheet 8. Yun yung worksheet associated with this work text, diba? So, yeah, hopefully matapos nyo to sa labs on Monday para fully equipped na kayo para sa worksheet 8. But perhaps you will need another 4 or 5 days to finish it. So let's move worksheet 8 to Friday next week. Okay, so I think that's it. Thank you guys for sticking around. Enjoy the rest of the day, and let's see each other again on Tuesday. Bye, guys.
Thank you, sir. Bye po.
All right.
Thank you, sir. Stay safe po.
Right. Salamat.
Thank you po,
By
sir.
the way, yung mga nag-recite nga pala, please comment your nicknames on the chat box. I got you, Gad. So, sino pa ba yung nag-recite na walang Teams account? I think everyone has a Teams account na. So, pa-comment na lang guys kung nag-recite kayo. Thank you. So, I'll end the meeting pero you can keep on commenting dun sa comment box.
Hi, sir.
Hi, Mary Rose.
Sir, magtatanong lang po sana ako if meron na pong submission pin for the reaction paper po.
Oh yes, punta kayo sa Canvas under assignments. May dalawa na akong bin na ginawa. Isa para kay interview with Russell, tas yung isa para dun sa AMAth 199 seminar.
Sige pa. Thank you po, sir.
All right.